Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next video of electronics. In this video we will solve two problems of electronics. Both these problems have been chosen from the book by Matthew N.O. Sadiku and Charles Alexander. Fundamentals of electric circuits. Okay. Now first we come towards statement of problem number 4. In this video we will solve problem number 4 and 5. Okay. Problem number 4, statement of problem number 4 is the total charge entering a terminal is given by Q equal to 5t sine 4 pi t millicoulomb. Calculate the current at t equal to 0.5 second. Okay. Yes students, here small m stands for milli. Milli means 10 raised to the power minus 3. Calculate the current at t equal to 0.5 second. Okay. Mathematically, the relationship between current I, charge q and time t is given by I equal to dq over dt. This implies that I equal to dq over dt equal to d over dt into q. This value of q is given. Okay. So in other words, we are just going to differentiate it, q with respect to time t. Okay. Then we will differentiate with respect to time. Dear students, here a table is shown. This is a table of basic formulas of differentiation of trigonometric functions. Okay, that is differentiation of sin x is cos x and differentiation of cos x is minus sin x. Similarly, it is shown that sin 2 pi is equal to 0 and cos 2 pi equal to 1. Okay, these two values will also be used in this problem. Okay, these basic formulas will also be applied, so these have been shown. Okay, so we will differentiate q with respect to time, and I will be represented in ampere, because current of unit of current is ampere, while here charge was given in coulomb. So in place of millicoulomb it will appear as milliampere, because now it has been converted into current I and unit of I is ampere. However, milli will remain the same, only this coulomb will be converted into ampere. Okay. Now at t equal to this, we will, in place of t we will use this value. Okay, so here we know that we have shown that this formula, that its value and value of this. So after simplification, current I becomes equal to 31.42 milliampere. Okay, quite simple. Here we have used that is during differentiation we have used these basic formulas, and this formula has also been applied that this sin theta 0, 30, 45, 60, 90 and so on. So sin 2 pi equal to 0 and cos 2 pi equal to 1. Okay, this formula was also used in our problem. Okay, now we come to next problem. Its statement is find the power delivered to an element at t equal to 3 millisecond. Milli meaning 10 to power minus 3 millisecond, if the current entering its positive terminal is I equal to 5 cos 60 pi t ampere, and the voltage is in part A V equal to 3I and in part B V equal to 3 di over dt. Okay, so we will use these conditions. Okay, here is I. When v is equal to 3, I, this portion part will be multiplied with 3, and in this part which has been obtained by multiplying it with 3, it will be differentiated with respect to t. Okay, we see part A, I is equal to this. Then this implies that v equal to 3, I equal to this into multiplied by this, it becomes so. And p is equal to vi, so this v will be multiplied with this, and hence it will become so and so. Okay, it will be converted into 75 cos square 60 pi t w, because unit of power is in watt w. So cos square 60 pi into, in place of t we have used the given condition that 3 milliseconds, that is 3 into 10 raised to the power minus 3. It will become here, dear students, 0.181 pi. Okay, because 60 into 3 180, and 180 divided by 1000, it will become 0.180 pi. Okay, 0.180. And we know that when pi appears as an angle, that is it is within cos square, so then it is taken as 180 degree. Okay, pi when appearing as angle, it is taken equal to 180 degree. But if pi appears outside the angle, then it is taken as 22 by 7, that is 3.14. Okay, so this is the basic difference in use of pi. Okay, when pi appears as angle, we take it equal to 180 degree, while if it appears outside the angle, then we take pi equal to 22 by 7, that is 3.14. We know that pi is a very special number. Its decimal representation is non-terminating and non-repeating. It goes endlessly. Okay, anyhow, simplification, this simplification comes 32.4 degree, and cos 32.4 degree is equal to 0.844, and it will be squared because here cos is in square. So simplification gives power p equal to 53.43 watt. Okay, now we come towards part B, in which I is equal to this, and di by dt, that is its differentiation with respect to t, becomes so and so. Okay, so and so, and v is equal to 3 into di by dt, so this factor will be multiplied with 3, and hence we will get this. Okay, next p is equal to vi, so minus 900, we have already calculated v, and this v will be multiplied with I. Okay, this I and this v both will be multiplied, and we will get this into this. It will become minus 4500 pi sine 60 pi t into cos 60 pi t watt. Okay, here then in the next step, in place of t we have used 3 milliseconds, that is 3 into 10 raised to the power minus 3. Okay, so it becomes this and this. So in both expressions we have replaced t by a 3 millisecond, so it becomes so and so. Okay, just simplification, nothing else. It again becomes 32.4, but here one time it comes as a sine theta, and one time it comes as a cos. Okay, sine 32.4 and cos 32.4, their values will be taken. Okay, now minus 4500 is appearing from the beginning, and in place of pi we have used 22 by 7, that is 3.14. Okay, decimal representation of pi, non-terminating, non-repeating. Okay, and then this is the value of sine 32.4 degree, and this is the value of cos 32.4 degree. Okay, and watt will appear along these, because power is always expressed in watt. Okay, after simplifying it becomes as minus 6290.68 watt. It can also be written as minus 6.29 kilowatt, because a kilo is equal to 10 raised to the power 3. Okay, next is problem number 6. We will solve this problem in our next video. Okay, till next video, Allah Hafiz.